What's up? I'm back at you with day 56. For today's video and tomorrow's video, I'm going to go through every single problem on the related rates review sheet. Today I'm focusing on problems 4 and problem 5. I want to make sure that we are really solid on that related rate review sheet so we can get the more straightforward problems down. So when we try the harder problems, they'll be a little bit easier because we know what we're doing. Okay, so problem 4, what it says is a 7-foot-tall basketball player is walking towards a 21-foot-tall light pole at a rate of 5 feet per second. What is the rate of change of the shadow length of the player? Again, what's going to be very important, I saw some of you guys doing this well today, some not so much, is it's going to be really important that we draw an accurate picture here. We label constants as numbers and never give them a variable at all. And things that are changing in our picture, we want to label them with variables, right? Letters. So what we have is a 21-foot tall light pole. That light pole is not going to be increasing or decreasing in length. It's going to be 21 the whole time. And we have a 7-foot tall basketball player. That basketball player will not change his height in this walk, so I'm going to label the 7-foot tall basketball player as 7. Okay. I do not want to call them H. I don't want to give them letters at all, ever in this whole process. Okay. So what's going to happen here is when the light is shining down on the player, the shadow is going to be cast behind the player. So we know that the shadow will be back here. And what we end up creating here are two overlapping triangles. Two overlapping triangles, which we know from geometry. Some of you guys had me for geometry. We looked at these problems back 2 years ago, right? Hopefully if you took geometry as a freshman, you looked at these kind of problems. What we have here is similar triangles. Now the tough part here, there's two tough parts to this. Figuring out what to label as the variables, right? And then writing a good equation. So here's what I know. The only other piece of information I know is that the player is walking towards the light, right? So sometimes I put a little arrow here to remind myself that the player is walking towards the light, which is going to give me a very different answer than walking away from the light, okay? So as the player is walking, that distance between the player and the light post will be changing, okay? So what I'm going to do is I'm going to label that distance between the player and the light post. I'm just going to call it letter X, okay? As a note, X only extends from here to here, okay? I'm not going to label that a number because I don't know, actually I never know what that number is in this problem. And even if I did, I'm not going to label that in my picture because it's changing. So when things are changing, they're varying, and I'm going to label them with variables. Okay, next, since the question is what is the rate of length of the rate of change of the length of the shadow, I'm going to need to name the shadow a certain variable. So you can call it kind of whatever you want. My S's end up looking like 5s. I think on the key I used an S. I'm going to use a Y here because I don't like the fact that my S's look like 5s. So I'm going to use a Y for that shadow length right here. Okay. So let's make a no column and start filling in things that we know. Well, here's what we know. We know how fast the player is walking. He's walking at a rate of 5 feet per second. So we know the rate of change of one of those two variables, X or Y. Well, X is the distance in between the player and the light pole, so that has to be shrinking at a rate of 5 feet per second. Okay? So I don't know x, but I do know that dx dt equals, and now we want to think about this. Is this going to be 5 or is this going to be negative 5? Well, here's how I think about it. As that player is walking towards the light, is that distance x growing or shrinking? Well, that distance x would obviously be shrinking, therefore dx dt needs to be negative 5. And that's literally all I know. In fact, in this problem, I'm never going to know x and I'm never going to know y. And in fact, I don't need to know either one to solve this problem. The rate of change of the shadow will be the same regardless of how close or far this player is. What I need is the rate of change of the shadow. The shadow I labeled y, so what I need is dy dt. Okay. Oftentimes our need is a rate of change, so make sure you write it as a derivative, right? I don't need y, I need dy dt. Okay. Now I need an equation that relates these variables. Okay, well, these would be right triangles, so we might be thinking Pythagorean theorem. However, since we never know x or y, we'll never be able to know what the hypotenuse is, right? So Pythagorean theorem gets thrown out. Anytime you see overlapping triangles, if that comes up on the AP exam, and you see overlapping triangles, you should think about similarity, right? We know that those triangles would be similar. So what I like to do is highlight the two triangles that I'm working on. What I really want you to understand here is that x, the variable I labeled x, is not the length of any side of any triangle. Okay, that's very, very important. I'm going to highlight in different colors the two triangles that we have here. Here is one of the triangles I have. Okay, that's one of them. Here's the other triangle I have. Okay. So all I'm going to do is match up the corresponding parts of the triangles and write a proportion. So here's what I'm going to do. I'm going to start with the easy part. I'm always going to compare big triangle to small triangle. So I'm going to start with the height of the big triangle, which is 21. And I can keep that number in my equation because 21 never changes. Over the height of the little triangle, which would be obviously 7. That has to equal the base of the big triangle. Here's where you need to be careful. A lot of students write x for the base of the big triangle. X is not the base of the big triangle. X is only this distance. That's not the base of the triangle. The base of the triangle is this whole distance. So the base of the triangle is x plus y. Very important to see that. Over the base of the yellow triangle, the littler triangle, which is y. Okay? So kind of a lot of tough stuff to get this thing set up. The nice thing is once you get it set up, the problem's very easy to solve. Now I don't want to do a derivative right now because I'd have a horrific quotient rule on the right side, and I'd have to end up I would need to know what x and y are, and I don't know what they are, and there's no way that I can ever figure them out. So scratch that. Let's just cross multiply and get this to a simpler equation. When you cross multiply here, we get 7x plus 7y equals 21y. Now one more step to just make it that much easier. I have like terms here, so I'm just going to subtract 7y from both sides. So I get 7x equals 14y. Now I'm able to do my derivative. And just remember, every time we do a derivative in related rates, we tack on d, whatever the variable was, dt. The derivative of 7x is simply 7, and then I tack on dx dt. The derivative of 14y is 14, and I get dy dt. The nice thing is, both x and y go away, so I don't need to know what they are, which is fantastic. Now I can just sub in for my dx dt, which I determined was -5. So I get -35 over 14 equals dy dt, which simplifies. Both of those things divide by 7. -35 divided by 7 is -5. 14 divided by 7 is 2. So I get dy dt, the rate of change of the shadow, is -5/2. We were measuring length in this problem in terms of feet and time in terms of second. So there we have it, problem 4. Let's take a look at problem 5. I'm going to do parts A, B, and C here. It's really imperative that you draw a good picture for problem 5. Okay? So obviously this is a right triangle. No, that's kind of a crappy right triangle. Let me draw it better. Okay. So the ladder is leaning up against a house, right? And so it says a 17-foot ladder is leaning against a house. The ladder begins to slide down the side of the house. Okay, and it says the base of the ladder is sliding away from the house at a rate of 8 feet per second. Now what I need to be careful on is I want to draw one good picture. One good picture here I can use for parts A, B, and C. If you draw a bad picture, you're going to have a hard time doing parts A, B, or C. All of them are going to be a struggle. So I'm imagining this ladder sliding down the house. Well, that's going to change the triangle. Okay? But some parts of the triangle in this problem will be changing, and some parts won't. So what I'm going to do is think about, first off, what won't be changing? Well, as the ladder slides down, the ladder is always going to be 17 feet long. So I'm going to write 17 right on the hypotenuse. I'm not going to call it C or Z. I'm not going to give it a variable because it isn't varying, and it won't in this problem. Okay? Now, the other two sides, right, as the ladder slides down, obviously the height of this triangle is going to be decreasing while the base is going to be increasing. Now, even though I know particular numbers for those to solve this problem, I'm not going to label them with numbers in my picture. That's a huge mistake. You're going to have a really hard time with parts, especially part C, but you'll also have a tough time with A and B. So I'm going to label the vertical part Y and the horizontal part X. Okay? Having that picture right there will be very helpful for you. If you have the numbers in there, it's not going to be helpful. Okay? You need to make sure you're doing that correctly. Now I can start figuring out what X and Y and dx dt and dy dt are. Okay? Your picture needs to have 17 labeled as the hypotenuse, and you need to have variables for the two legs of this right triangle. Okay? All right, so here's what I want to do. I'm going to read through this problem again and start adding to my know list. It says the ladder begins to slide down the side of the house. The base of the ladder is sliding away from the house at 8 feet per second. So the base of the ladder is down here, and it's sliding away from the house. So I know X is changing, right? And it said it's at a rate of 8 feet per second. So I know I'm going to end up knowing dx dt. My question for you, and when I was working with students on this today, I asked them the same question. Is dx dt 8 or negative 8? Well, dx dt has to be 8 because, as we notice, that side of the triangle, that x side, is going to be lengthening. It's increasing its size. It needs to be positive 8. Now, the top of the ladder is going to be going down the house, like this. Now, we don't know dy dt, right? That's going to end up being our need. But what will dy dt's sign end up being? Well, dy dt's sign will end up being negative. Should end up being negative here. And we can tell that ahead of time. Okay, so it says, how fast is the ladder sliding down the side of the house? So that will be, our need will be dy dt. At the instant, the base of the ladder is 15 feet from the house. Notice that unit, 15 feet. That is not a rate. The distance, the base of the ladder from the house is x, so I know x equals 15. Okay. That's all that's explicitly given. But if you notice, I gave you x, and so we know one of the legs, and we know the hypotenuse. We can always find the third side of a right triangle, right? So we can figure out what y is at that instant by doing 17 squared minus 15 squared. Well, 289 minus 225 is 64. The square root of 64 is 8. Or you should just know 8, 15, 17 is a Pythagorean triple. So that tells us at the instant the base is 15 feet away. That means that y must be 8 feet big. They may say, well, I thought y was supposed to be negative. No, dy dt is supposed to be negative. Y obviously has to be a positive number here. Right? We have to have, side lengths have to be positive. Okay? In retrospect, I wish I would have picked a different Pythagorean triple, but that's okay. Now, if you didn't take the time to solve for y equals 8 now, you're going to realize that you need to come back and find that y equals 8 at a different time. Okay? Our equation, what relates those things? The reason I want you to label your picture well with variables for variables and constants for constants is we can write an equation as accurately as possible, right? Our equation has to be x squared plus y squared equals 17 squared. We're allowed to use 17 here because 17 isn't changing, which is nice because when we do the derivative, that's just going to become 0. After I find my equation, then I do the derivative. And it's not until I do the derivative that I plug in everything I know. Okay, so make sure you don't plug in now. Don't plug in until we do the derivative. The derivative will be 2x dx dt plus 2y dy dt equals the derivative of 17 squared is 0. I'm going to go ahead right now and divide everything in my equation by 2. Which gets that out of there. And now I can plug in. So what goes in for x? Well, that would be 15. What goes in for dx dt? That would be 8. What goes in for y? Now here's the part. If you didn't solve y right at the beginning, you'd need to stop and solve it now because you don't know it. But we already did that. It's 8. And dy dt is unknown. So 15 times 8 is 120, which I can see that I'm going to actually end up dividing by 8s, right? So in my key, I just left it as 15 times 8. So most people would probably do that right there. 15 times 8 is 120. I'm going to subtract that 120 over and divide by 8, and dy dt is going to equal negative 15 feet per second. So our figuring out that dy dt should be negative did come true. The one thing I like to do now, circle that answer, right? That's our answer with the correct units. I like to also add that to my no list because it might be helpful down the road. Okay? So that's part A. Part B. All of our no's transfer down, but we have a new need. Because it says, at that very instant, what is the rate of change of the area formed? So my need now is dA dt. Now I chose X and Y in my picture. Some people might have chosen A and B. I didn't want to choose A and B because I knew I was going to need dA dt, and I don't like having A meaning two different things, area and a side length. Okay? So let's look back at our picture and see if we can figure out an equation for area. Now I know the area of a triangle is half base times height, but I'm not going to write A equals half BH because I didn't label the base B and I didn't label the H H. If I did, I'd use that equation. I labeled the base X and I labeled the height Y, so I'm going to say area equals half XY. Now, some people might say X times XY over 2, right? Or if you use B and H, BH over 2. I prefer this way for doing, so I don't have to try and do a quotient rule here. So I do need to do a product rule here. So what I'm going to look at is because I see two variables and they're separated by multiplication. So I'm going to think of my first term as half X. And I'm going to think of my second term as y. Okay? So I have to do a product rule to do this derivative. Now I'm going to go ahead and do the derivative. The left side of the equation is easy. The derivative of A is simply dA dt. Okay? Now I have to do a product rule while simultaneously remembering that every time I do a derivative, I need to tack on d whatever the variable is, dt. Right? So product rule says derivative of the first times the second plus the first times the derivative of the second. So the derivative of the first is simply half. The derivative of half x is half, but I need to tack on dx dt. That's the derivative of the first times the second y. Plus the first half x times the derivative of the second, which is simply dy dt. Now, when I look back at my no column, I know all four of the things I need to know, leaving only dA dt as unknown. So dA dt would equal half dx dt. What was that? 8 y 8 plus half x was 15 and dy dt ended up being negative 15. Now 8 times 8 is 64 and half of 64 is 32, but I'm not going to be able to cut 225 in half because it's an odd number. So I'm going to leave this as 64 over 2. And again, remember this negative right here is going to turn this into a subtraction problem, minus 225 over 2. Now, when I look at that, 64 minus 225, I know dA dt now is going to be negative. And 64 minus 225, well, I'll flip it around and do 225 minus 64. 1, 12 minus 6 is 6. So I get negative 161 over 2. So that's my answer. Units. Area is measured in square units. So in this case, it would be feet squared. per time unit, which in this problem is seconds. So that is the rate of change of the area. Because dA dt is negative, we know the area of the triangle is decreasing at that instant. Okay. Part C. Again, all of our no's still transfer down, but we have a new need. At that instant, what is the rate of change of the angle theta? So I need the rate of change of theta, so I need the theta dt. And theta, the angle, right, because there are two angles we might be thinking about, form between the base of the ladder and the ground. So, like right here's the base of the ladder, here's the ground, here's where theta goes. So let's just add theta into our picture there. And now I have to write an equation using theta. Well, okay. I can write a sine equation using theta. I could write a cosine equation using theta. Or I could write a tangent equation using theta. Now, tangent is the one I avoid the most because the derivative of tangent is secant squared theta, and that takes more time to evaluate than evaluating cosine theta or evaluating negative sine theta, the derivatives of sine and cosine respectively. Okay. On the key, I did this problem using sine theta. However, to make it more interesting, I'm going to use cosine theta in this problem just to show you that it works just as well. It doesn't matter what you choose. So I'm going to choose cosine theta to be my equation. Well, cosine we know from SOHCAHTOA, ka is adjacent over hypotenuse. So cosine theta would have to be x over 17. So I write that as my equation. If you do it with sine theta, compare. See if we get the same answer. If we both do it right, we should get the same answer. The one thing I like to do, okay, before I do the derivative, I like to fix this a little bit so I have a coefficient times x. So I want to rewrite this as cosine theta equals 1/17 x. Hopefully we know that those are identical things. It'll just make my derivative a little bit more intuitive when I do it. Okay, so here I go. I'm going to do my derivatives along the way. Things we know. Derivative of sine theta is cosine theta. But the derivative of cosine theta is negative sine theta. So my derivative here ends up being negative sine theta. But again, I have to remember to tack on d theta dt. By the way, if you forget to do that d theta dt, we'll never get what we need. So if you're ever stuck at a point where like, hey, I don't even have what I need in my equation, it's probably because you forgot to do this step right here. Okay? So I got negative sine theta d theta dt equals the derivative of 1/17 x. Well, that's simply 1/17, and then I got to tack on dx dt. Okay? Now, I'm going to easily be able to plug in for dx dt. 1/17 is a constant. That doesn't give me a problem. This should be unknown because that's what we're solving for. But now I need to figure out what negative sine theta is. Okay? And now, the nice thing is, after I do the derivative, I can use numbers. Whereas in my equation, I had to have this as a variable x, while this was allowed to be a constant 17. Okay? But now we can actually plug in for the values of all these things. So negative sine theta, I need to figure out what that is. Well, it's going to be negative opposite over hypotenuse. Well, my opposite was y, and my hypotenuse was 17. But I don't have to use y over 17. I can use the numbers now. Y ended up being 8, right? So now I can use opposite 8 over 17. d theta dt equals 1 over 17 times dx dt. Well, dx dt, and it was 8. So simplifying that, I get negative 8/17 d theta dt equals 8/17. Now to get d theta dt alone, I'm going to multiply both sides by the reciprocal of my d theta dt. Okay, and all these numbers are going to turn to 1, except for negative 17 is going to turn to negative 1. These will all cancel, and I get d theta dt equals, don't forget about the negative, negative 1 radian per second. I measure angles in radians rather than degrees. Which reminds me of a good math joke. When mathematicians graduate from college, do they get degrees or do they get radians? All right, guys, that's problem 4 and 5. I'll hit you tomorrow with a video that clearly explains questions 1 through 3, getting ready for those problems. Tomorrow in class, we're going to be working on those harder, more challenging problems with groups and making posters of our answers. So be prepared for a challenge tomorrow. We want to do the best we can on those really hard problems, but we have to nail the problems from the review sheet, the more straightforward ones. All right, guys, talk to you later. 2 trains, bye.